Hello and welcome to Maths with Jacob. This lesson will focus on drawing a table. Drawing a table is a useful strategy because it can sometimes reveal relevant patterns, which could lead you to the correct answer. You can then work systematically through the table using any patterns that are obvious. Example 1. Susie is able to save $7 each week to buy her mum a birthday present. How long will it take her to save over $50? Okay, now here are the weeks, one after the other. The first week she saves 7. The next week she saves another 7, which is 14. The next week she saves another 7, which is 21. So the 7 times tables takes you up to the 7th week, where she saves $49 in total, but the question is asking over $50, so she has to go to the 8th week, where she saves $56. So the answer is 8 weeks. Example 2. Fred ran a cake stall for 8 days. On the first day he made $9. Every day after that he made $3 more than the previous day. How much money did he collect on the 8th day? How much money did he make in total? On day 1 he collected $9. On day 2 he collected $12 because he made $3 more. On day 3 he collected $15 because he made $3 more. We keep adding $3 onto the previous total, and we get to day 8 because that's what the question's asking. On the 8th day he collected $30. The total, of course it says how much money did he make in total. You add all those amounts up and you get $156 in total. Example 3. Bob picks 20 marbles from a jar. Each marble is blue or red. For every blue marble he picks, Bob picks 4 red marbles. How many red marbles does Bob pick? Now, when he picks the first blue marble, he picks 4 red marbles. That means he has a grand total of 5 marbles. That's after he's picked 1 blue. When he picks another blue, that means he's got a total number of 2 for blue. He picks an extra 4 red ones, so he has a total count of 8 for red, which gives him a grand total of 10 marbles. When he picks the third blue marble, he has a total number of 3, which means he picks an extra 4 red ones to give him a total number of 12 for the red. 3 blue plus 12 red gives you 15 as the grand total. And finally, when he picks his fourth blue, he picks an extra 4 red ones to give him a total number of 16 for red, which gives him a grand total of 20 marbles. So the question is asking, after he picks his 20 marbles, see there? See? We want to know how many red marbles he picked. Well, there they are. He picks a total number of 16 red marbles. Example 4. Tim and Mary are running in the cross-country carnival. Tim runs 3 kilometres every 17 minutes and Mary runs 5 kilometres every 29 minutes. Who is running faster? So, when Tim runs 3 kilometres, that takes him 17 minutes. After he does 6 kilometres, that takes him 34 minutes. 9 kilometres, total of 51 minutes. 12 kilometres for a total of 68 minutes. 15 kilometres for a total of 85 minutes. Now we'll go to Mary. When she does 5 kilometres, that takes 29 minutes. 10 kilometres takes 58. 15 kilometres takes 87. So here is the common distance. 15 kilometres for Tim takes 85 minutes. 15 kilometres for Mary takes 87 minutes. Hence, Tim is running faster. Example 5. 1 litre of lemon juice is mixed with 4 litres of water to make a lemon drink? How much water is needed for 7 litres of lemon juice? Well, lemon juice, if we have 1 litre, that gives us 4 litres of water are needed. For 2 litres of lemon juice, we need 8 litres of water. For 3 litres of lemon juice, we need 12 litres of water. So for each extra litre of lemon juice, we need an extra 4 litres of water. So for 7 litres of lemon juice, we need 28 litres of water. That's what the question's asking. Example 6. There are 8 swimmers in a relay team. The first team member swims 400 metres and each subsequent team member swims 50 metres less than the previous swimmer. How far does the last team member swim? So swimmer 1 swims 400, swimmer 2 350, swimmer 3 300. So you keep taking 50 metres off as you go along. When you get to the 8th swimmer, swimmer 8, he swims 50 metres. So there's a great example how you can solve problems by drawing a table and by picking patterns.